I can use the volume combine process to spatially join a 3D velocity volume with a 2D velocity volume. For many projects, this would be all that was required to depth convert. But for this dataset, the two velocity surveys clearly have a sharp discontinuity, which might cause problems during depth conversion later. To check this, configure the time depth conversion to use the combined velocity, and convert the traces into depth. A sharp discontinuity can be seen in the depth traces, as predicted. Using polygons, it is possible to create blending zones between the surveys. Create a polygon defining the limits of the 2D survey, a polygon defining the limits of the 3D survey, and a polygon defining the blend zone from 3D to 2D. For this example, I need to use the extrapolate process to extend the 3D velocity, so that both velocity volumes spatially coexist within the blend zone outside the 3D survey. I also need to extrapolate the 2D velocity to fill the space between 2D lines, and to place both the interpolated velocity volumes on the same survey grid. Use the map view operations to create a constant horizon with value 0. Set the limits to the polygon defining the 2D survey velocity. Rename your horizon to keep track of your work. Use the map view operations to erase a hole in the horizon using the 3D-2D blend polygon. Use the map view operations to create a constant horizon with value 1. Set the limits to the polygon defining 3D survey. Rename the horizon to keep track of your work. Use the map view operations, horizon maths, to merge the constant 0 and constant 1 horizons together. The formula is merge h1, h2. Rename the horizon to keep track of your work. Use the map view operations interpolate extrapolate to fill the empty space between the values 0 and 1. And finally, use process volume maths to merge the two volumes based on the horizon template just created. Select the two volumes and apply a merge formula that scales the volumes based on the template value. The great thing about this workflow is you can easily adjust the size and shape of the blend zone polygons, enabling complex survey combinations. As always, QC results. Here is the original unblended 3D-2D velocity. Compare that with the blended velocity. Here is the original velocity once more. This is the original two-way time section. Now depth converted using the unblended volume. Note the artifact. Update the time depth conversion model to use the blended velocity. The artifact is removed. Let's finish by showing the blended velocity model in time once more. If you have questions or would like to discover more, then visit our website at www.doug.com. And remember, have fun with Insight.